Hello, welcome to our class Introduction to Power Systems Protection. We are going to be looking at what is power systems protection, power systems equipment, why protect power systems, basic power equation, sources of fault in power system protection equipment slash devices, characteristics of protection equipment. What is power systems protection? Simply defined, an art and science of setting relays of fuse such that under normal or tolerable conditions, the system remains closed while they open under intolerable conditions, isolating the system from power supply. It also can be defined as a branch of electrical power engineering that deals with the protection of electrical power systems from faults through the isolation of faulted parts from the rest of the electrical network. Power systems equipment. Power systems equipment are generally every system that allows power to pass through it or perhaps uses power for its function or generates this electrical power can be regarded as power systems equipment. We have categorized them here to include devices which uses electric power to carry out their functions. They are motors, washing machine, electric fans, refrigerators, transformers, etc. We also have devices which generates electric power, and they include fossil fuel generators, hydro generators, and the rest of that. So why protect power systems? One of the reasons we protect power systems is to maintain the continuity of supply by isolating the faulty system. Let's take, for instance, that a fault from your refrigerator could affect every installation in your house, and all of a sudden, there is total blackout in your house. No supply to any other socket, no supply to the fan, just because of a fault emanating from your refrigerator. But when we have a protective system, it can afford to block that fault, ensuring that this fault does not go beyond that particular installation, keeping every other installation in your house and your supply safe, and current will continue to flow in the system. So another one is to reduce repair and maintenance costs. Of course, we have this as one of its function to reduce repair and maintenance costs, because since you have afforded in blocking the current flowing from the refrigerator, the fault current from the refrigerator from affecting other devices in the house, you have ensured that you have reduced the number of repairs you are going to make in that house. And of course, you have reduced your maintenance, because the number of things that will be damaged, assuming it's a fault current that has the capacity of destroying something, you have stopped it using that protective system. A third one is to ensure safety of environment and personnel. This is also very essential. Every protection system has this as a principle of operation to ensure safety of environment and personnel. For instance, if there is fire hazard, if you have a good protection system, it can stop any occurrence of such issue, because it will stop the fault from it before it develops into something that becomes uncontrollable. So, basic power equation. Electric power from our basic physics is defined as P is equals to IV, where P is electric power in watts, I is electric current in amps, P is potential difference in volts. Every electrical system or equipment has its tolerable rating for I, V, or both, under which it can perform as desired. When these tolerable ratings go outside the system's acceptable values, a fault is said to occur. Hence, we must protect the system against these faults and their damaging effects, because of course they must surely come. There are faults that we never prepare to see them, but they come on their own. And now we look at the sources of faults in power system. What are the sources of these faults? Since they don't come on their own, what empowers them? What brings them to visibility? How do we get to see these faults? How do they come into our systems? Now, one of the ways they come in is through lightning. Now, lightning, we know, is a natural occurrence. Most times during windstorm or during rain, you get to see thunderstrokes. Now, these thunderstrokes actually release electrons, and these electrons find their way to our electrical installation. And by doing that, they increase the voltage of the electrical installation, thereby causing stress on these our installations, and hence a fault situation can occur, because when the voltage gets beyond normal, it can damage the system and perhaps even cause fire. We have another one, which is mechanical damages such as car colliding with electric pole, tree branch falling on a line. Of course, situations like this occur. Generally, we'll see them, cars collide with pole, we see line resting on a tree branch and the rest of that. These things can actually lead to a very serious fault, which we call short circuit, because it has a capacity of bridging two lines, and this will lead to a high current flowing through the system, which is dangerous and can cause fire. You can see that from our figure that we have here. We also have aging of systems insulation. By insulation, we mean the ability of a material to withstand current flow. Technically, we call it dielectric strength. By this, we believe that the insulation material should be able to oppose to a great extent the flow of current between it. And most times, these insulation materials, they decay over time. Sometimes it could be also as environmental issues, maybe moisture, maybe dust, and so many other things can lead to the decay of these insulations. And when they age, like this, short circuit can occur in the system. Power system protection equipment or devices. Now, to protect our system from fault, which we know definitely will occur in the system, how do we achieve that? We have some devices here that we have stated. They include fuse, which protects the system against high abnormal current by melting. Looking at the basic fuse figure that we have here, you will see clearly there is a tiny element between two metallic caps. That tiny element is actually called a fusing element. Now, what it does is to allow current flow through it within its rating. Whenever a current above its rating flows through it, it ruptures. By rupturing, we mean it breaks, it opens, it damages itself. And this, of course, it does to protect the device, disconnecting the device from actually the source of supply. We also have circuit breaker. The circuit breaker protects the system by opening under fault. Now, how does it do this? The circuit breaker has what is called a trip coil inside of it. And whenever a current above the value that that trip coil can carry, the trip coil becomes energized and develop enough strength to pull the contacts of the circuit breaker and open it. Now, the beauty of the circuit breaker and the fuse is that in the course of the fuse damages itself while trying to protect the system, but the circuit breaker just opens itself. So one can always come in and correct whatever is the problem. We also have lightning arrestor. The lightning arrestor protects the system against induced voltage due to lightning. Like we know, this lightning will always occur, is a natural occurring phenomena. So when these electrons are released, because of the function of this lightning arrestor, it traps these electrons and confidently sends them to the earth, thereby shielding our system from the attack of these lightning. Characteristics of power system protection equipment. For our power system protection equipment, they must have these fundamental characteristics for them to be effective. One is that they must be reliable. Reliability means they should be active. When we want them in operation, they should be there. The second one is selectivity. Remove only faulty equipment or devices. We don't expect it to go and take out another equipment that has no fault. We expect that our protection system should be able to take care of any fault that is coming within its region and not jumping its region to go and isolate other equipment. We also have sensitivity. Sensitivity has to do with to dictate slight values of acceptable, slight changes in acceptable values. You know, of course, why sensitivity in measurement, like we have learned, measurement will teach you that sensitivity is the ability of a device to see little changes from its actual value. And that is what the protection system does here. Its ability to see slight changes above the value we have programmed it, or we have said this is acceptable. Then we also have stability. Stability here has to do with operate only under fault. That is, we don't expect this system to operate except there is fault. And in doing this, time must be taken to calculate. That's why we say it is a science, must be taken to calculate to ensure you understand the nature of the fault so that the system does not operate under false alarm. Maybe there's a current that may jack up, but that's not a fault and it shouldn't operate. So we expect that your system should be stable enough to only operate under fault. Then speed, like we know, is the ability for the the circuit to respond very fast and quick and without delay. Thank you. For this class, I know you have enjoyed it. See you again.